Take a moment to gaze at your reflection, your face, your hands, the contour of your head. Now picture yourself journeying 70,000 years into the past to encounter a distant relative. Isn't it astonishing? They would appear nearly identical to you. The same stature, the same cranial capacity, the same facial features. If you tidied them up, gave them a haircut, and dressed them in today's attire, they could stroll through any city street right now without attracting a second glance. But this is where the story becomes truly peculiar. Travel back an additional 70,000 years to around 140,000 years ago, and you would still observe much the same. Go back to the dawn of Homo sapiens, 200,000 years ago. Apart from a few subtle variations, you are seeing the identical species, the same physical form, the same biology. For 200 millennia, we have remained unchanged. Even as we constructed empires, created computers, unlocked atomic energy, and launched spacecraft beyond the sun's realm, our physical forms remained static. Our biological evolution ground to a halt, or more precisely, it decelerated to a near standstill, approximately 70,000 years in the past. The explanation behind this is among the most captivating tales in the entire chronicle of humanity. And if you are listening to this to drift off to sleep, that's wonderful. That is precisely the purpose of these recordings. So perhaps consider subscribing, and by all means, share in the comments your location and the current time where you are. I delight in seeing a sunrise over Tokyo, midday in London, midnight in Los Angeles, all listening at once. It is rather lovely when you pause to reflect on it. At this point, you may wonder, hold on, evolution unfolds over millions of years. How can we possibly determine that it paused only 70,000 years ago? That's an excellent inquiry. And the reply is that we know because nature provided us with an experiment, a group for comparison. You see, 70,000 years ago, an event occurred that ought to have pushed human evolution into high gear, yet the opposite occurred. It signified the point when biology ceased to be paramount and culture assumed command. That event is known as Toba, and it nearly ended humanity before we had truly begun. Envision this scene. Roughly 74,000 years ago, within a margin of a few millennia. By then, modern humans had existed for some 130,000 years, yet we were not thriving. We were dispersed across Africa, tentatively beginning to venture outward. We were intelligent. We possessed language. We crafted tools. But we were merely another species struggling for survival. Not yet exceptional, not yet dominant. Simply one variety of human amid several, contending for resources alongside Neanderthals in Europe and Denisovans in Asia. Then, on the island now known as Sumatra in Indonesia, a volcano named Mount Toba erupted. However, this was no ordinary eruption. It was a supervolcano. The most colossal volcanic explosion in the past 2 million years. The blast was so immense that it propelled 670 cubic miles of rock and ash into the atmosphere. That quantity of matter could cover the whole of the United States beneath 2 feet of volcanic deposit. The ash cloud encircled the entire globe within weeks. It obscured the sun. Worldwide temperatures fell by as much as 15 degrees in certain areas. Most humans lived, but the temperature decline was sufficient to destroy plant life and thoroughly devastate ecosystems. Animals perished in enormous quantities. Vegetation withered. Water supplies grew polluted with volcanic ash. This phenomenon is termed a volcanic winter by scientists. It could have endured for years, perhaps even decades. According to some models, the climatic aftermath persisted for 1,000 years. Envision surviving such a time, uncertain whether the skies would ever brighten again, uncertain if the animals would ever reappear, uncertain if your offspring would have food in the coming year, or the year following that. Genetic evidence indicates that human populations plummeted dramatically. Some estimates suggest that the total number of reproductive humans remaining on Earth was roughly 10,000 individuals. In the realm of species, our journey takes us into the fossil record, where ancient bones reveal secrets about evolutionary stasis. Then we also examine the rare exceptions, The tiny, intriguing ways that humans truly changed over the past 70,000 years are worth exploring. By the conclusion, you will grasp one of the most significant shifts in all of life's history on our planet. That key instant when a single creature ceased to be merely shaped by evolution and began to guide it. So, make yourself cozy, relax. Let's journey back 70,000 years ago, to the point where human evolution seemingly halted and a new era began. Actually, 74,000 years in the past, an event occurred that nearly wiped out our species before we had hardly started. It wasn't a falling asteroid, nor an extraterrestrial attack, nor a worldwide plague. The cause of our near extinction was an Indonesian volcano that chose to erupt with a power equivalent to millions of nuclear weapons detonating all at once. This was the Toba eruption, the most massive volcanic blast in 2 million years. An event so colossal that today's catastrophes seem like small troubles. When Toba exploded, it wasn't a simple eruption. It practically broke itself apart, hurling immense amounts of debris into the sky, changing the planet's climate for many human generations to come. We're discussing an incredible 2,800 cubic kilometers of ash, stone, and volcanic matter thrown into the upper atmosphere. For context, think of Mount St. Helens still remembered as a huge eruption, released roughly 1 cubic kilometer. Toba's blast was 2,800 times greater. Its force was such that volcanic fragments traveled up to 3,000 meters distant. Deposits of Toba's ash have been discovered in India, the Indian Ocean, and East Africa. These areas would have been entirely smothered by poisonous gray ash. Yet the immediate blast wasn't the most devastating. The truly dreadful phase followed. All those substances launched into the stratosphere created a thick cover enveloping the whole globe. Sulfur dioxide, mixed with atmospheric moisture, forming tiny droplets of sulfuric acid that bounced incoming sunlight away from Earth. In just a few weeks, worldwide temperatures started to fall. After a few months, the world entered what researchers term a volcanic winter, an extended time of darkness and chill that could continue for years, maybe even decades. Imagine the reality of this. Picture yourself as a person alive 74,000 years ago. Your existence is difficult enough already. You survive by hunting and foraging, dwelling in tiny groups, always on the move in search of sustenance. Your continued life relies wholly on your understanding of the landscape, the rhythms of seasons, the paths animals take during migration, and when plants bear fruit. Your forebears have passed down this wisdom across countless generations. But then, abruptly, everything alters. The heavens become gray, ashes descend like snowfall, blanketing all in a poisonous layer. Temperatures crash down, vegetation stops thriving, creatures begin to perish, streams and lakes fill with sediment. This was no short-lived emergency. Scientists estimate the volcanic winter endured for 6 to 10 years. 6 to 10 years, with little sunlight, poor harvests, ecosystems breaking down. For a species living day to day, reliant on steady food supplies, this spelled doom. The consequences didn't stop once the ash settled. The climate upheaval set off an extended chilly era that stretched over a millennium. World temperatures fell by around 3 to 5 degrees on average. In certain areas, especially closer to the poles, the decline was far greater and more extreme. A drop of 3 to 5 degrees may seem trivial. We see larger temperature shifts from summer to winter. However, this refers to the average worldwide temperature maintained across hundreds of years. Such a shift alters whole ecosystems completely. Forests retreat. Prairies become semi-arid lands. Water supplies vanish. The animals that humans relied on either perished or moved to places that were unreachable. For our ancestors, this marked the world's end, and humanity almost perished along with it. Proof of this disaster lies within our DNA. Each cell of your body holds the genetic imprint of events that unfolded 74,000 years ago. It shows we were nearer to annihilation than at any other moment in human history. This area of research seems almost like sci-fi, yet it rests on firm molecular biology. Our ability to decode the story of human population collapses mirrors how we interpret tree rings or ice cores. We examine patterns in our genetic material that arise only under particular conditions. The crucial proof originates from mitochondrial DNA. In contrast to nuclear DNA, which you inherit from both parents, mitochondrial DNA is passed solely through your mother. She received it from her mother, who got it from hers, forming a continuous maternal chain stretching back to the dawn of humanity. And this is why it's incredibly useful for examining ancient population numbers. Mitochondrial DNA changes at a fairly consistent pace, roughly one mutation every 300 to 500 years. By sequencing this DNA from individuals across the globe, geneticists can construct a family tree that reveals how all maternal lines are connected. They can determine when various branches diverged. More critically, they can gauge the ancient population's size from the genetic diversity present today. When researchers performed this analysis, they discovered something astonishing. Every person alive today, 8 billion of us, can follow our maternal lineage to a group of between 3,000 and 10,000 people who existed roughly 70 to 80,000 years ago. Just that, 3 to 10,000 individuals. The genetic variety across all of humankind is smaller than what you'd see in a single chimpanzee troop or in an average gorilla group. We rank among the largest mammals with the lowest genetic diversity on Earth, and the timeline aligns perfectly with the Toba eruption. Yet the mitochondrial data is only the start. Researchers also examined Y chromosome DNA, which travels from father to son in an unbroken paternal chain. A different source of genetic information, a different inheritance pattern, yet the outcome was identical. A significant population bottleneck roughly 70,000 years back shrank human genetic variation to a tiny portion of what's expected for a species as old as ours. Next, they turned to standard nuclear DNA, the type inherited from both parents. The same narrative emerged. Every genetic study using every known technique leads to the same verdict. A catastrophic event struck humanity about 74,000 years ago. An event that dropped our population to such tiny figures that extinction seemed inevitable. Reflect on how near it came. 3,000 individuals. That's fewer than a typical high school's capacity. Less than the population of many small towns. Scattered over a whole continent, possibly two if any groups endured in Asia. These bands were so separated that they could pass months or years without meeting other people. This was more than a simple population drop. This was humanity teetering on the very brink of annihilation. And additional clues confirm the demographic crash. The archaeological record from that era reveals a sharp decrease in the count of human settlements. Places that had been inhabited steadily for millennia were abruptly deserted. Stone tool traditions that had been dispersing throughout Africa halted their spread. Exchange routes that transported rare materials over vast distances disintegrated. The archaeological pattern matches precisely what you would anticipate from a species undergoing an almost complete population collapse. Some scientists have challenged the Toba catastrophe hypothesis. They note that not every climate record indicates severe cooling precisely at 74,000 years ago. They observe that certain archaeological sites appear to indicate continuous occupation across that time. They suggest perhaps the bottleneck was not as extreme or abrupt as the genetic data implies. However, here's the key point. The genetic evidence is truthful. Something caused a dramatic reduction in human genetic diversity during this era. Perhaps it was Toba. Or maybe Toba combined with a chain of other climatic catastrophes that occurred around the same period. Perhaps the volcanic winter acted merely as the final push that sent already struggling communities over the edge. The precise details are of great interest to archaeologists and climate experts. Yet, from the perspective of human evolution, the outcome is what truly counts. Our ancestors passed through such a drastic bottleneck that it forever changed the genetic path of our species. So let's explore what a genetic bottleneck actually entails. When a population shrinks to a tiny size, a huge amount of genetic variety is lost. Random mutations that had built up over time vanish because the people who carried them perished before having offspring. Unique genetic traits disappear. The entire gene pool shrinks in a major way. Imagine a deck of cards with thousands of unique patterns, but now only 3 or 4 remain. Even if the population later rebounds to millions or billions, the variety in the gene pool never quite returns to its former richness. From then on, every generation is just shuffling that same small set of cards. This has deep consequences for evolution. Evolution relies on genetic differences, Natural selection needs a range of traits to choose from. When a population becomes genetically uniform, evolution has less raw material to act upon. With fewer mutations, there are fewer opportunities for advantageous adaptations. Lower diversity leads to a slower pace of evolutionary change. The Toba bottleneck essentially halted the physical evolution of humans. It becomes even more precise. By examining which sections of the human genome display the least diversity, geneticists can pinpoint the areas that the bottleneck impacted most heavily. And this is where things become truly fascinating. The genes responsible for fundamental physical traits, like body size, skeletal structure, and facial features exhibit very little variation among all human groups. Why is that? It's because the bottleneck fixed a particular physical blueprint. The survivors of Toba, somewhere between 3,000 and 10,000 people, carried a specific body shape, unique skeletal details, and a distinct array of physical attributes. And since the surviving population was so tiny, those features became permanently embedded in the human lineage. Consider this perspective. Prior to Toba, human populations likely had a broader range of physical diversity. Tall and short people, sturdy and slender frames, varied skull shapes, and different bone densities, the usual variety you'd find in a widespread species. However, when over 95% of the population perished, that diversity vanished. The few who remained were not a balanced cross-section of human diversity. They were simply the ones who, by chance, were in the right spot at the right moment, blessed with the perfect mix of fortune and survival abilities. Their physical traits then became the blueprint for every human that followed. This explains why modern humans, whether in the Arctic or the Sahara, share such striking physical similarity. Sure, there are differences in skin tone, hair type, and eye shape, but these are only surface-level adjustments to local environments that developed fairly recently. The core human body design, the skeleton, internal organs, and overall physical structure has remained virtually the same for 70,000 years. Every one of us is constructed from the same foundation, because that foundation was set during the bottleneck. And the genetic data reveals another astonishing fact. Not only did the bottleneck cut down our genetic variety, it also favored certain characteristics. Keep in mind, those who made it through were not a random sample. They survived because they possessed traits that helped them withstand a long-lasting catastrophe. Intelligence was key, the ability to come up with novel solutions when traditional methods no longer worked. Social cooperation was also essential. No single person could have made it through the volcanic winter on their own. Only communities that collaborated, pooled resources, and stayed united managed to endure. Adaptability. Arguably the most crucial quality, the flexibility to change their diet when familiar foods vanished, and the willingness to relocate to new lands when their old homes became impossible to live in. Being mentally agile enough to pick up new abilities rapidly. These are not physical attributes. They are behavioral and mental qualities. And here's the key takeaway. The bottleneck applied such strong selective pressure to these traits that they became nearly universal among all humans. Every person living today traces their lineage back to ancestors who made it through by being intelligent, willing to work together, and resourceful. These mental qualities, even more so than any physical attributes, are what truly define humanity. And they were forged during those harsh 1,000-year stretches when anything short of top-tier mental capability led to demise. Yet, there is another consequence of the bottleneck that is far more nuanced. When a group's numbers plummet and later rebound, a phenomenon known as founder effects begins to occur. Those who endure the bottleneck only possess a fraction of the original group's genetic variety. As their offspring expand and populate new areas, they all operate from that constrained genetic toolkit. Genetic drift, the mechanism where particular genes become more frequent or rarer by sheer luck, grows far more influential in small groups. Characteristics that were uncommon prior to the bottleneck may turn widespread after it, not due to any advantage, but simply because the people who had those traits just happened to live. This implies that certain features of modern humans may not be adaptations in the slightest. They could simply reflect which particular individuals survived and were passed along, like the specific curve of our chin, perhaps not an adaptation for language or any function, possibly just an accidental trait that occurred among the survivors of the bottleneck. The exact ratios of our arms and legs might be perfected for effective walking on two legs, or they might be merely fixed characteristics from that pivotal instant when the group shrank. We can't always separate true adaptations from the results of founder effects. Yet the genetic data suggests both contributed to forming today's humans. The mitochondrial DNA reveals another intriguing fact. That group of roughly 3,000 to 10,000 individuals who survived. They were not spread out equally. According to genetic studies, the majority were in Africa, likely gathered in several refuges, areas that stayed livable even through the harshest times of the climate upheaval. Maybe East Africa, where the landscape formed small climate zones that softened some of the temperature swings. Or perhaps Southern Africa, where food from the coast could have offered steady sustenance when interior regions turned unlivable. The precise spots are still argued over, yet the overall picture is obvious. Humans reduced to a handful of tiny patches of habitable land and held on to life there for millennia. Some groups may have endured beyond Africa, perhaps in areas of Asia or even Europe. However, if they did exist, they contributed no offspring to the current human family tree. The genetic proof is crystal clear. Every human alive today looks back to that African group that survived the bottleneck. Any other people, if they were there, either went extinct or eventually merged back into the larger population. This explains why Africa has the greatest genetic variation among all continents. That's where humankind weathered the disaster. That's where numbers started to grow once more. It's our species' true home ground. And here's the truly sobering reality. We were fortunate. There was nothing guaranteed about humans outlasting Toba. Had the explosion been more massive, the volcanic winter stretched further, or if the survivors had been in tougher places, we would not exist today. Human development would have stopped 74,000 years back, with a species that had much potential but just couldn't survive a catastrophe on a global level. The fossil history is filled with evolutionary failures, species that flourished for millions of years and then disappeared when the environment shifted. We came dangerously near to becoming just another one of those small notes in the geological history. Yet we endured, and that survival came with a price we still experience today. Our genetic bottleneck cemented our physical shape. It shrank our genetic variation to a mere fraction of its normal state. It left us susceptible to hereditary disorders that wouldn't trouble more varied species, but it also solidified the mental and social characteristics that would later enable us to rule the earth. We came out of Toba with bodies unchanged but minds supercharged, a species that would halt physical evolution, yet continue cultural evolution without end. The Toba disaster was the turning point, the instant that launched humanity onto a fresh evolutionary path. Before Toba, we were merely one more hominin species, likely quite similar to Neanderthals, Denisovans, or a dozen other human kin. After Toba, we became something different, a species molded by enduring the most terrible catastrophe possible, whose evolution moved from bodily adaptation to mental creativity, and that exchanged genetic variety for mental harmony. We were unaware of this back then. Naturally, those survivors clustered in their African sanctuaries, struggling to locate nourishment, gazing at the overcast sky, pondering whether the world would ever be normal again. They had no clue they were starting a fresh chapter in human evolution. They were simply attempting to get through another day. Yet their triumph in that dire effort transformed everything about the course of human evolution. They laid the genetic groundwork for all of future humanity. And that foundation, shaped in turmoil and disaster, would become both our biggest constraint and our strongest asset. Approximately 70,000 years ago, an extraordinary event occurred in our species. An event that would forever alter the direction of human evolution. This was not a genetic change. It was not a sudden enlargement of the brain. Our ancestors had already grown sizable brains hundreds of thousands of years before. No, this was something else. It was the instant when culture grew stronger than biology, when learning took over from evolution as our primary means of adapting. Anthropologists refer to it as the cognitive revolution. Yet, that term doesn't fully describe what truly occurred. It wasn't that humans abruptly gained thinking ability. Neanderthals and Denisovans could think. Even earlier, humans possessed notable mental capabilities. 70,000 years ago, human thought became linked, methodical, and additive. We gained the capacity to resolve issues, recall answers, pass them on, and expand on them over generations. The archaeological record is astonishing. Prior to 70,000 years ago, stone tools evolved gradually. A hand axe from 300,000 years ago resembles one from 100,000 years ago. Across different continents and species, separated by hundreds of millennia, the technology remained basically the same. Then abruptly, around 70,000 years back, everything shifts. The archaeological record in Africa bursts with creativity. Advanced stone blades emerge, crafted with methods that take years of practice to perfect. For the first time, bone implements appear: fishing hooks, needles, awls, refined tools built for particular uses. Yet the true transformation wasn't in the tools themselves. It lay in what they meant: standardization. Sites, separated by hundreds of miles, reveal matching tool patterns. This is not convergent evolution, where separate groups independently come up with similar answers. This is cultural transfer, humans instructing one another precisely in crafting particular tools, exchanging completed items across great spans of land, building common technological customs that moved more swiftly than any genetic change could. And then, there is the art. Prior to 70,000 years ago, there is almost nothing in the human archaeological record that qualifies as artistic expression. Occasional scratch marks on bones, perhaps some ochre colorants, which could have been used for adorning the body, nothing organized, nothing that obviously indicates symbolic thought. Then from about 75,000 years ago in South Africa, at Blombos Cave, we uncover ancient artifacts, ochre pieces carved with geometric designs, intentionally formed, unmistakably ornamental. These weren't practical implements. They were items made to communicate ideas: delicate shell beads, meticulously pierced and threaded as adornments, and enigmatic markings etched into rock, hinting at tallying or documenting. This is symbolic thought, the capacity to have one thing stand for another, crafting symbols and artifacts that hold significance beyond their material presence. It may seem straightforward, yet it is truly one of the most advanced mental skills found in nature. Most creatures cannot achieve it whatsoever. Even our nearest evolutionary cousins display only the barest hint of symbolic reasoning. By 40,000 years ago, human artistry had grown remarkably refined. The pace of biological evolution is quite leisurely. For a helpful genetic change to become common in a group, it can require many thousands of generations. If the surroundings shift before that mutation has a chance to spread, then all that evolutionary effort goes to waste. In contrast, cultural evolution happens much more quickly. When one person comes up with a more effective way to hunt, it can be adopted by the entire tribe in just a generation. Within a handful of generations, nearby groups have also picked it up through trading or simply watching others. Over the course of 100 years, it can travel across an entire landmass. That difference in speed is nearly beyond comprehension. Biological evolution works over periods ranging from thousands to millions of years, whereas cultural evolution can bring about huge transformations in just a few decades or even years. When a group of humans meets a fresh environmental challenge, they don't have to sit around waiting for natural selection to deliver helpful genetic changes. All they require is one smart person to devise a fix, and then that fix can quickly reach everyone who could benefit from it. This marks the point when humanity ceased evolving, at least in the conventional sense. It's not that our genes stopped mutating, they didn't. Rather, genetic transformation ceased to be our main way of adjusting to the world. Whenever the environment shifted, humans didn't rely on evolution to increase our height or provide us with denser hair. Instead, we created clothing, constructed dwellings, and harnessed fire. Fire, let's discuss it, because it's an ideal illustration of culture taking over from biology. Fire has been utilized by our ancestors for at least 400,000 years, possibly even more. However, during the cognitive revolution, the use of fire became methodical and widespread. Every band of humans had mastery over fire. They could reliably ignite it and keep it burning for as long as needed. People understood the characteristics of fire and applied it to numerous tasks, clearly for cooking, but also for warmth, illumination, defense against predators, crafting tools, and managing the land. Fire enabled humans to endure environments that would normally be lethal. During the Ice Age, Neanderthals in Europe required large frames and high metabolic speeds to keep warm. Modern humans simply built fires. When our own ancestors entered Europe, there was no need to wait hundreds of millennia for biological cold weather changes. They draped themselves in animal hides and gathered near flames. That's cultural adaptation in practice. Garments are another excellent case. Crafting tailored apparel is no easy task. One must hunt animals, strip the hides, scrape away remnants, treat them so they don't decay, cut them into shapes, and stitch them into place with bone needles and thread made from plant fibers or animal sinew. Each step demands particular knowledge and implements. Yet once humans discovered this method, likely about 70,000 years ago, according to genetic studies of the lice that inhabit clothes, which branched off from head lice, people could live in any environment, whether tropical Africa or Arctic Siberia. Location no longer mattered. They simply changed their attire. No physical evolution was necessary. Contrast this with all other living creatures. As mammals spread into various climates, they developed different kinds of fur. For instance, polar bears boast thick, water-repelling pelts. Desert foxes have thin fur that helps release heat. That development required millions of years. Human beings achieved a comparable result via culture in only a few millennia. And here is the truly amazing aspect. Once clothes erased the evolutionary pressure for cold tolerance, our bodies ceased evolving along that path. Anatomically, we stayed as tropical beings, tall, lean, and lacking good insulation. Our biology never quite matched our geographic spread, because it didn't have to. Culture managed the adjustments much faster than biology ever could. A similar pattern appeared with what we ate. Human beings are meant to be omnivores who consume a fairly varied mix of fruits, vegetables, meat, nuts, and anything else that's handy. That's what our digestive systems are designed for. Yet cultural breakthroughs let us consume items that should be impossible for us to digest. Take grains as an example. Raw grain is hardly digestible for people. We don't have the specialized gut microbes that animals adapted to seeds possess. However, we discovered that if you grind grain into flour and then cook it, it turns into a calorie-dense food. This is a cultural process, not an evolutionary one. The same thing applies to dairy. Most grown humans cannot digest lactose. That's the normal condition for mammals. As babies, we create the enzyme needed to break down milk, but after weaning, that ability fades. From an evolutionary standpoint, this is completely logical. However, about 10,000 years in the past, certain groups in Africa and Europe started keeping livestock. All of a sudden, they had cow, goat, and sheep milk, a plentiful supply of energy and nutrients. The catch is that most adults cannot tolerate it. Then, in a handful of populations, a genetic mutation appeared that made lactase persistence possible, the capacity to digest milk sugars into adulthood. This mutation indeed spread via natural selection, given its huge advantage. But here's the fascinating part. Humans didn't hold off for that genetic change. They began eating dairy right away, employing cultural methods like fermentation to make yogurt and cheese with less lactose, along with other processing and cooking techniques that further reduce lactose. By the moment the genetic adaptation emerged, people had already culturally adjusted to eating dairy. This shows a new pattern in human evolution. Culture takes the lead, while biology trails behind, if it ever catches up. More and more, biology doesn't change at all, since culture tackles challenges far quicker than natural selection ever could. Another development by humans also completely altered the course of evolution. These were complex social systems that shielded those who were weaker. In other species, natural selection is harsh. Those with genetic flaws often die before they can reproduce. That's the standard way evolution operates. The weak perish, the strong endure, and beneficial genes become more common. However, humans, particularly following the cognitive revolution, built communities that consciously cared for their vulnerable members. A wolf born with bad vision would be in serious trouble. Hunting would be hard, and survival unlikely. A person born with poor eyesight in a human group simply needs a companion to craft a spear and guide them to the game. They can still be valuable in other roles, perhaps skilled at making tools, processing plants, or caring for children. Findings from that era reveal people who lived for many years with disabilities that would normally have been deadly. Skeletons show signs of serious arthritis, healed broken bones, lost teeth problems that would have made it impossible to hunt or gather alone. Yet they survived because their communities looked after them, providing food, shelter, and protection, keeping them alive in spite of their limitations. This is indeed compassion, but it also greatly interferes with natural selection. By shielding those with genetic drawbacks and enabling them to live and have offspring, you're blocking natural selection from eliminating those genes from the gene pool. Gradually, this reduces the force of selection. Beneficial genes keep spreading, but harmful ones don't vanish as fast anymore. The human genetic pool grows more varied since selection doesn't weed out variations so harshly. And humans were okay with this because we found another solution: teaching. If a person struggles with hunting due to missing some genetic edge like strength, speed, or coordination, you can make up for it by instructing them in improved methods, tools, and tactics. Cultural learning can surpass genetic shortcomings in ways that would be unattainable for any other creature. This set up a feedback cycle. Richer cultural knowledge allowed more people to live and reproduce, irrespective of genetic fitness. With more survivors came more possible innovators. More innovators accelerated cultural change, and faster cultural change further reduced the need for biological evolution. The species that had once been molded by harsh natural selection during the population bottleneck now built a buffer against selective pressure. They were shielding themselves from evolution, and language was the crucial element behind all of this. Thanks to language, complex knowledge could be passed on. It enabled planning and teamwork, abstract thought, and symbolic reasoning. And unlike genetic traits, language could spread in no time. A clever invention by one person might be taught to the whole clan in just one afternoon, and then to nearby groups in a matter of weeks, and across a whole continent within a single generation. Just think about biological evolution. A helpful mutation in one person can take thousands of years to reach even a tiny group. The difference in speed is millions of times greater, literally millions. Cultural evolution works on scales of years or decades. Biological evolution, on the other hand, works on scales of thousands or millions of years. By 50,000 years ago, human technology was shifting so quickly that the archaeological record couldn't keep up. Every couple of millennia, stone tool styles were completely transformed. New materials were added, and fresh techniques emerged. That's many times faster than biological evolution, and the speed kept increasing. Between 50,000 and 10,000 years ago, there was more technological progress than in the entire 2 million years of human evolution before that. Tools like spear throwers, bows and arrows, fishing gear, grinding stones, pottery, boats, sleds, ropes, baskets, and musical instruments. Every new invention lifted another pressure from natural selection. Each tool reduced our reliance on physical strength and increased our reliance on know-how and skill. People also formed intricate social ranks and specialized roles. No longer did everyone have to master every skill. In a hunter-gatherer band after the cognitive revolution, you'd find experts. Some were especially good at tracking animals, others at crafting tools. A few were masters at identifying and preparing plants. The finest storytellers kept the group's oral traditions alive. Shamans, or spiritual guides, who grasped life's symbolic and ceremonial sides. This specialization meant that natural gifts in one domain mattered less. You didn't have to be speedy, strong, clever, and socially skilled all at once. You could shine in your own field and depend on others for the rest. This was only achievable through language and elaborate social structures. And it eased selection pressure even more, because now even very specialized people, those who might be seriously lacking in some abilities, could still survive and flourish by playing to their strengths. The cognitive revolution also granted humans the power to reshape their surroundings on a scale never before seen. Other creatures do alter their environment. Beavers erect dams. Termites build intricate mounds. But humans raised environmental transformation to an entirely new plane. They harnessed fire to shape landscapes, setting forests ablaze to create open grasslands that drew in game. They constructed sophisticated shelters that stayed cozy and warm no matter the weather outside. They redirected water, built storage systems, and invented methods for preserving food, enabling them to survive through lean times. Each change to the environment added another shield against natural selection. If you can mold your surroundings to meet your needs, you no longer need to adapt biologically to the environment. That's the major transformation that occurred during the cognitive revolution. For billions of years, life on Earth was molded by evolution to match its environment. After the cognitive revolution, humans started reshaping their surroundings to suit themselves. And once this began, there was no turning back. There was no returning to a time when biological evolution was the main way to adapt. Cultural evolution was just too strong, too quick, too efficient. Any group that attempted to lean only on biological adaptation would be immediately surpassed by groups that used cultural adaptation. By around 40,000 years ago, as modern humans spread across the planet, meeting and gradually supplanting Neanderthals and Denisovans, the struggle was not truly biological. Neanderthals had the physical edge. They were stronger and hardier, better suited to Ice Age environments. Yet modern humans possessed superior cultural evolution. Finer tools, smarter organization, and more flexible adaptation. In the clash between biology and culture, it was culture that came out on top. That's the reason human evolution essentially came to a halt around 70,000 years ago, at least when it comes to big changes. Not because we had achieved the peak of evolutionary excellence. Far from it. In many respects, we were actually quite poorly built. Painful lower backs, challenging childbirth, delicate eyes, and a slow journey to adulthood. Yet all of that ceased to be an issue because our adaptation no longer relied on evolution. Instead, we adapted through culture, and cultural evolution moves millions of times faster than biological evolution. Before natural selection could even bring about a helpful genetic mutation, cultural ingenuity had already found 1,000 different solutions to the same problem. The species that had just barely made it through the bottleneck had crafted the ultimate approach to survival. It wasn't about having mightier physiques, swifter reactions, or superior camouflage. It was about knowledge that could be passed on, built upon, and endlessly reshaped. We became the very first species on Earth to develop the knack of ceasing to evolve, or at least in the conventional sense. And that transformation altered everything. By around 15,000 years ago, Homo sapiens had achieved something never before seen in Earth's biological history. They had triumphed, not merely endured, but utterly prevailed. Humans now inhabited every continent with the exception of Antarctica. The Neanderthals had vanished, as had the Denisovans. Homo sapiens was left as the sole human species still around. Yet this victory did not come without a price. Repercussions that would profoundly change the course of human evolution in ways our forebears could scarcely dream of. For millions of years, a single brutal force had driven human evolution: natural selection. Those individuals whose features aided their survival and reproduction would pass those very features down to their offspring. Individuals lacking those advantageous traits perished before reaching reproductive age, causing their genetic variations to vanish from the population. Across countless generations, this unforgiving cycle shaped our species, weeding out flaws, magnifying advantages, and steering us towards ever better fitting with our surroundings. Yet around 70,000 years ago, something shifted. Something that would ultimately dismantle the very mechanism that had molded our species from its earliest days. Anatomically, modern humans started methodically removing the selective forces that had been carving out human evolution over millennia. They did this not on purpose. They had no way of understanding what they were doing. Yet with each fresh invention, each social progress, each novel tool, they were eliminating yet another pressure that had been fueling evolutionary transformation. It all began with the predators. For our primate forerunners, being preyed upon was among the most powerful selective forces one can conceive. Those who were quicker could flee from leopards. Those who were more clever could spot hidden predators before the fatal moment. Groups that worked together better could fend off assaults that would have overpowered a lone individual. Any characteristic that boosted survival in the face of predators was favored by selection. Every vulnerability was weeded out. However, Modern humans, equipped with advanced weaponry and organized team strategies, methodically erased that very pressure. Cave lions that had preyed on human ancestors for eons were wiped out by 12,000 years ago. Cave bears that vied for the same refuges disappeared. Saber-toothed cats that had winnowed out the slow and frail from early human communities vanished entirely. Digs from that era narrate the tale. Settlements of early Homo sapiens reveal organized hunting of the top predators that had once stalked them. Bones of cave bears bearing cuts from stone tools. The remains of cave lions heaped up in garbage piles. These were not mere acts of defense. Humans were deliberately pursuing the hunters, wiping out creatures that threatened dangers to their offspring and their settlements. By around 10 millennia ago, across most human-inhabited areas, the remaining predators were creatures too tiny, too scarce, or too cautious to present major dangers to human groups. The evolutionary pressure for features that assisted in predator evasion, which had guided primate development for 65 million years, essentially ceased to function. Over the span of millennia, the force of natural selection acted gently, influencing who had children rather than who survived. Now, contrast that with the selective forces that molded human development through the genetic bottleneck and its aftermath. In a single generation, famine wiped out half the people. Entire family lines vanished due to climate catastrophes. Predators removed the frail and sluggish. These were intense selective forces, so potent they could spark swift. Take the spread of lactose tolerance over 8,000 years, it offered a small nutritional edge. That's a prime example of relaxed selection, evolution moving at a snail's pace compared to the rapid changes of earlier times. 2,000 years ago, most people dwelled in communities where reaching childbearing age depended little on genetic quality, though not entirely free of it. Disorders that stopped reproduction or led to early death still faced natural rejection. Yet the vast spectrum of ordinary human genetic differences was freed from intense selective pressure. In cities like Rome, Athens, Chang'an, Teotihuacan, and many other urban hubs, people with wildly varied genetic backgrounds all lived long enough to have children at about the same rate. The tall and the short, the powerful and the feeble, the quick and the slow, the keen-sighted and the myopic, all were raising families, passing their DNA to the next generation. That's why researchers in human genetics observe barely any meaningful biological shifts in our species over the past 70,000 years. Evolution ceaselessly generates new genetic diversity in every community. It wasn't that helpful mutations ceased occurring, but rather that the selective forces which usually sift through those variants, boosting the good ones and weeding out the bad, had been lifted by human society. The rise of modern medicine pushed this even further. Come the 19th century, medical breakthroughs were saving people who would have perished from infections, childbirth difficulties, accidents, birth defects, and countless other health problems that were deadly in earlier times. The 20th century introduced antibiotics, surgical techniques, vaccines, and therapies for inherited conditions. Now people carrying genetic variants that were fatal only a handful of generations back could grow up, start families, and enjoy complete lifetimes. In developed countries nowadays, more than 99% of newborns reach reproductive age. Pause and consider that for a second. 99% in evolutionary terms. That's nearly total removal of selection. If virtually everyone has offspring, no matter what their genetic makeup is, natural selection comes to a halt. The characteristics transferred to future generations become an almost arbitrary snapshot of today's genetic pool, rather than a refined collection of the most advantageous features. That's not to say human genetics remain entirely static. Random drift continues its work. New mutations appear in separated groups as well. Some gene versions may increase in frequency purely by luck, yet the kind of selection that drives a population toward improved fit with its surroundings has essentially ceased within humanity. We retain genetic diversity that influences intellect, physical prowess, resistance to illness, and sharpness of senses. All the traits that faced heavy selective forces throughout our evolutionary past. People carrying gene variations that would have been removed by natural selection 100,000 years ago now play full roles in modern communities, adding their DNA to the generations ahead. Some worry this signals that humans are decaying, piling up detrimental mutations that selection once would have purged. Yet this view misinterprets the reality. We aren't decaying. We've simply stopped evolving biologically to match our surroundings because we've built a world where physical adaptation isn't required to live on. Someone with weak eyesight doesn't rely on genetic evolution to see better, they rely on eyeglasses. A person prone to infections doesn't require a gene that boosts immunity, they require antibiotics. A person who finds cold climates challenging doesn't need innate biological changes, such as the Neanderthals, for instance, required warm clothing and central heating to survive. For every ancient challenge that once pushed natural selection forward, modern humans devised cultural, technological, or medical workarounds. And these innovations operate far more swiftly than evolution ever managed. While genetic adaptations require countless generations, technological fixes can emerge in just a few years or decades. This core truth explains why human evolution came to a standstill some 70,000 years in the past. Well, not precisely at that instant, naturally. It was a gradual slowdown that accelerated as agriculture, city life, and advanced technology took hold. Yet, the direction was established during the recovery from that ancient population bottleneck. Human groups began crafting the cultural richness and technological skill that would ultimately take over from biological evolution as the main engine of adaptation. In a very genuine way, we became the first species in Earth's history. We surpassed the need for evolution, forging an environment where natural selection no longer meaningfully molds our species. Cultural and technological innovations deliver adaptive benefits far quicker and more efficiently than any genetic mutation could. The consequences of this shift are immense. This means that in terms of anatomy, genetics, and biology, modern humans are essentially locked in the state we achieved around 70,000 years ago. We are not evolving towards larger brains, more robust bodies, or improved resistance to illness. We are not genetically adjusting to our current environment. We are merely preserving the genetic status quo. We maintain the vast richness of human genetic variation, but without the selective pressures that would ordinarily steer that variety in a specific direction. However, if robust natural selection indeed stopped acting on human groups millennia ago, the fossil record ought to contain evidence of this. We ought to be able to follow the anatomical shifts, or their absence, that signal the conclusion of human biological evolution. And indeed we can. The bones speak truth. And this is where the story becomes truly captivating. For when you truly inspect the physical clues, the skeletal remains, the teeth, the ancient DNA stretching back 70 millennia, you encounter something that defies expectation. You witness stasis, a pause in evolution, a biological freeze frame that has held steady for 3,000 generations. Allow me to demonstrate what this means. In 2017, archaeologists digging in Morocco made an astonishing discovery at a site known as Jebel Hau, skeletal remains that are 315,000 years old. These individuals were not yet fully modern. Their skulls were longer and more flattened compared to ours. Their brow ridges were heavier, and their faces jutted forward more. Still, they were drawing near to the modern form. One could discern the beginnings of modern human characteristics, emerging from older, more primitive shapes, now fast forward to 195,000 years ago. The Omo remains from Ethiopia bring us even nearer to contemporary anatomy. The cranial vault became taller, the face grew flatter, and the brow ridges diminished. Evolution was unmistakably occurring. Each successive generation saw more changes accumulating. The fossil evidence reveals a steady transformation of human anatomy towards the modern configuration. Then, leaping to 160,000 years ago, we find the Herto skulls, also in Ethiopia. At this point, we are observing what paleoanthropologists describe as nearly modern humans. Had you encountered one of them walking down the street, you might have done a double take, but you would not have assumed they belonged to a different species. The fundamental architecture was already in place. A high rounded skull, a flat face, small brow ridges, and a well-defined chin. The evolutionary direction is unmistakable. Between 300,000 and 100,000 years ago, human anatomy underwent rapid change. Brains enlarged, faces grew more delicate, and body proportions shifted. This is the signature of evolution in the fossil record. Consistent, directional, transformation propelled by natural selection. Yet around 70,000 years ago, something peculiar took place. The changes came to a halt, not a gradual deceleration, but a full stop. Look, for instance, at the Skul and Kafse cave remains in Israel. These individuals were anatomically modern humans who lived between 90,000 and 120,000 years ago. Their skeletons are basically identical to those of people alive today. They share the same cranial capacity, the same bodily proportions, the same dental structure, the same everything. Now consider the Hofmeyr skull discovered in South Africa. At 36,000 years old, it is also completely modern. One could swap it with a skull from a present-day South African population, and anthropologists would find it difficult to tell them apart without carbon dating. The Cro-Magnon remains from France date to 28,000 years ago. These are the celebrated early Europeans who made elaborate cave paintings and crafted sophisticated tools. Their anatomy is entirely modern. Interestingly, Cro-Magnon skeletons exhibit slightly sturdier bone structure than present-day Europeans, probably because they led far more physically strenuous lives. Yet the fundamental blueprint remains identical to our own. Let's fast forward to 10,000 years ago. The Natufian people of the Middle East possessed a completely modern anatomy. 5,000 years ago, the ancient Egyptians who built the pyramids had the same physical structure. 2,000 years ago, the Romans constructing their empire also had modern bodies. Do you recognize the pattern? For the last 70,000 to 100,000 years, the human skeleton has stayed remarkably consistent. There have been hardly any alterations in skull shape, no meaningful shifts in body proportions, and no evolution of new physical traits. One might say that biological evolution came to a halt when our ancestors made it through the Toba catastrophe and acquired the cognitive abilities that distinguish our species. Now, let's turn our attention to brain size, because here, the evolutionary slowdown becomes even clearer. Throughout most of human evolution, brain volume grew continuously. Homo habilis, our first tool-making ancestor who lived about 2.8 million years ago, had a brain volume of roughly 600 cubic centimeters. That's relatively tiny, approximately 40% the size of a modern human brain. Homo erectus, who appeared around 1.9 million years ago, averaged about 900 cubic centimeters. They possessed larger brains, more sophisticated tools, and a greater capacity to adapt to unfamiliar surroundings. Early Homo heidelbergensis, the shared predecessor of Neanderthals and modern humans, had brains around 1,200 cubic centimeters, bringing it closer to present-day dimensions. By 300,000 years ago, both Neanderthals and early modern humans had average brain volumes of 1,400 to 1,500 cubic centimeters, comfortably within the range of people today. For more than 2 million years, the human brain expanded by roughly 850 cubic centimeters, a truly enormous change. Bigger brains brought better problem solving, more complex social behavior, and an enhanced ability to learn and pass on cultural knowledge. Natural selection clearly favored intelligence, and the fossil record shows a consistent growth in brain size as a result. But then, around 100,000 years ago, brain volume reached a plateau and simply stopped increasing. The modern human brain's size averages between 1,300 and 1,500 cubic centimeters, exactly the same range as humans from 100,000 years ago, the same range as humans from 50,000 years ago, the same range as humans from 10,000 years ago. In fact, some studies hint that the average size of the human brain has in fact diminished a little over the past 20,000 years. This isn't because we are becoming less intelligent, but rather because we have developed such elaborate social structures and gathered so much cultural wisdom that we no longer need as much brute computational power. We can depend on shared intelligence instead of relying solely on an individual mind. Yet even that decrease is minuscule, possibly a reduction of about 10% over a span of 20,000 years, and only in certain groups. The fundamental structure has not changed at all. Now contrast that with the preceding 2 million years, when brains were doubling in size. The difference is pronounced. Something fundamentally shifted in human evolution around 70,000 to 100,000 years ago. The relentless drive for larger brains that had propelled human development for millions of years simply disappeared. The skeletal evidence paints an identical picture across the board. Human height has fluctuated over the past 70,000 years, but the scope of variation hasn't altered. There are groups that are short and groups that are tall. Today we see both short and tall populations, just as we did 50,000 years ago, with no progressive trend, only variation around a stable average. Dental morphology, the shapes and sizes of our teeth, has stayed the same. Ancient humans had identical tooth patterns to what we see in modern populations. The same number of teeth, the same basic forms, and the same arrangement within the jaw. Limb proportions have also remained unchanged. Humans adapted to cold climates usually have shorter limbs and stockier physiques, while those adapted to hot climates tend to have elongated limbs and slimmer frames. This pattern became established long before 70,000 years ago and has stayed fixed ever since. The Inuit people of the Arctic share body proportions similar to humans who lived in cold regions 30,000 years ago. The Maasai people of East Africa have body proportions comparable to humans who inhabited hot regions 50,000 years ago. What is especially striking is what hasn't evolved. Modern humans lack any specialized skeletal adaptations for agriculture. Even after 10,000 years of farming, we have developed no unique bone structures for using tools, despite tool use being essential for human survival over millions of years. We also lack evolved anatomical features for wearing clothes, constructing shelters, or any of the other cultural behaviors that define human existence. This stands in stark contrast to earlier human evolution. Between 2 million and 100,000 years ago, the fossil record shows dramatic physical transformations. Homo erectus, for instance, developed longer legs for efficient, long-distance travel. Neanderthals developed sturdy skeletons suited to icy environments, while early modern humans had more slender frames. Once every few hundred millennia, the fossil record shows obvious directional shifts, evolution at work. However, for the last 70,000 years, there's been little change. The archaeological evidence paints a contrasting picture. Although human bodies stayed the same, culture grew immensely more intricate and varied. This is precisely the pattern we'd anticipate if cultural change had taken over from biological evolution as the main force behind human adaptation. Consider stone tool technology. Between 2.6 million and roughly 300,000 years ago, tool designs shifted at a very gradual pace. For more than 1,000,000 years, the same fundamental hand axe remained in use. Whenever new tool forms emerged, they diffused slowly, over hundreds of millennia. This pattern fits a species whose tool-making skills are mostly inherited. Individuals who crafted better tools had more children, and over immense stretches of time, groups slowly developed enhanced tool-making capabilities. However, starting around 300,000 years ago, and especially after 70,000 years ago, the speed of technological innovation picks up sharply. New tool varieties emerge and spread quickly, including blade technologies, microliths, and multi-component composite tools. Inventions that formerly required hundreds of millennia to appear and disseminate now emerge and circulate within just a few thousand years by 40,000 years ago. Human technology shifts so rapidly that archaeologists can determine the age of archaeological sites based on their tool collections. Every few millennia, distinctly novel tool styles appear. This is cultural evolution, ideas transmitted through learning and imitation, not through genetics. This same trend shows up in artistic expression. The first indisputable art ochre engravings discovered in South Africa dates back to around 100,000 years ago. By 40,000 years ago, humans were producing intricate cave paintings, sculpted figurines, musical instruments, and decorative items. This artistic flourishing occurred with no accompanying changes to human bodies. Identical brain volume, hands, and eyes, yet cultural manifestations were vastly different. Consider also how people obtained food. 50,000 years ago, humans were hunter-gatherers, utilizing a broad variety of plant and animal resources. By 10,000 years ago, humans had started domesticating plants and animals, shifting toward agriculture. 5,000 years ago, people dwelled in cities with specialized jobs and elaborate trade systems. Every one of these shifts signifies a huge transformation in human food procurement and social organization. Yet none of these changes demanded biological evolution. The humans who erected the earliest cities possessed the same physical form as the hunter-gatherers of 40,000 years prior. The transformation was cultural, not biological. This marks a species that has broken free from the bounds of evolution. Physical adaptation via genetic mutation requires hundreds of millennia. Cultural adaptation through learning and invention can occur within just a few generations. Once humanity passed that milestone, once we gained the mental and linguistic capacity to produce and pass on intricate culture, biological evolution started to become mostly unimportant for our survival. Ancient DNA evidence validates this trend with astonishing accuracy. In 2010, researchers released the initial version of the Neanderthal genome, put together using DNA taken from bones that are 40,000 years old. It marked a groundbreaking moment. For the very first time, we were able to directly contrast the genetic blueprint of long-extinct human relatives with the genome of today's humans. The findings indicate that people outside Africa today possess roughly 2% Neanderthal ancestry. This genetic material originated from mating that occurred roughly 50,000 to 60,000 years in the past, as early modern humans initially migrated out of Africa and came across Neanderthal groups in the region of the Middle East. Yet, here is the truly astonishing part. That Neanderthal genetic material has remained almost unchanged across 50 millennia. Those identical DNA segments that were introduced into our ancestors during those ancient encounters are still found in humans alive today. They have not transformed into anything different. They have not been removed by the process of natural selection. They simply persist quietly within our genetic makeup, operationally the same as they were 50,000 years ago. A number of those Neanderthal genetic variations influence traits such as immune system responses and skin pigmentation. That these elements have remained for 50,000 years with little alteration indicates that evolutionary pressure on modern humans has been minimal at most. If powerful natural selection were at work, we would anticipate that those genes would have either become universal across all individuals or been completely wiped out. On the contrary, they have simply drifted at steady rates across many hundreds of generations. The identical trend is observed with Denisovan genetic material. Present-day Asian and Pacific Islander groups contain Denisovan ancestry variations that were introduced into our lineage between 40,000 and 50,000 years ago. Once more, there has been very little alteration across thousands of generations. The genetic material from those mixing events that took place while humans were still employing stone implements is almost the same as the copies found in current populations. Even more impressive are the investigations into ancient human genomes belonging to our own kind. Researchers have successfully decoded DNA samples from human fossils covering the last 45,000 years. Foragers from glacial Europe, the earliest agriculturalists from the Near East, and old nomadic herders from the Central Asian plains. What they discovered is an extraordinary persistence of genetic patterns. In the year 2014, scientists released the complete genome of a modern human from Siberia who lived 45,000 years ago. His genetic code revealed he belonged to a group that gave rise to both European and Asian lineages. From a genetic standpoint, he was fundamentally a modern human, not an ancient variety that would subsequently transform into a different type. A fully modern human who existed 45,000 years ago and whose genetic profile would slot easily into the diversity of contemporary humans. A study from 2016 analyzed the genetic material from 14 ancient foragers who inhabited Europe from 35,000 down to 7,000 years in the past. These individuals survived the last ice age, observed the disappearance of Neanderthals, and created some of the most advanced stone implement techniques known in humanity's prehistoric era. Their genetic data showed an unbroken ancestral line connecting them straight to modern-day Europeans. There were no substantial evolutionary transformations, no appearance of fresh genetic variations that would suggest powerful natural selection, only slow blending and movement of groups that were already genetically like us today. What is especially revealing is what these ancient genetic records fail to demonstrate. They lack signs of any recent growth in brain volume. They show no continuous selection for intellectual capabilities. They reveal no development of novel metabolic beyond a few specific examples we'll revisit later. Adaptations or immune functions are absent. Instead, these remains show humans who were already genetically modern 40,000 years ago, living as hunter-gatherers, and their descendants would eventually develop farming, construct civilizations, and craft written language without any notable biological changes. Through these ancient genomes, we can follow particular human lineages far back in time with extraordinary accuracy. For instance, the San people of southern Africa represent one of the deepest, most ancient branches of the human family tree. Genetic studies indicate that they separated from other human populations roughly 100,000 to 150,000 years ago. Yet their DNA is unmistakably that of modern humans. The genetic gap between a San individual and a Norwegian is tiny, especially compared to the vast distance between a chimpanzee and a bonobo II species that diverged about 1 to 2 million years ago. This shows that all humans alive today share a very recent common origin, and our lineages have experienced minimal evolutionary change since they separated. We are all just variations on the same basic genetic blueprint established before 70,000 years ago. The contrast with earlier human evolution could not be starker. Between 2 million and 300,000 years ago, human evolution was rapid and had a clear direction. Every few 100,000 years, new species emerged. Homo erectus, Homo heidelbergensis, Neanderthals, Denisovans, early modern humans. Each had distinctive anatomical features. Each was adapted to its own environment. Each represented a clear evolutionary split from earlier forms. The fossils from this period reveal dramatic changes in skull shape, brain size, body proportions, and dental characteristics. If you compared a Homo erectus skeleton from 1.5 million years ago with a Homo heidelbergensis skeleton from 500,000 years ago, the differences would be obvious even to a casual observer. These were distinct species evolving along separate paths. But compare a modern human skeleton from 70,000 years ago with one from today, and you would struggle to find any meaningful differences. Same species, same anatomy, same fundamental genetic design. Evolution has not just slowed, it has effectively stopped. This biological stillness coincides almost exactly with the emergence of behavioral modernity. That full suite of cognitive and cultural abilities that define our species, symbolic thought, complex language, technological creativity, and large-scale social cooperation. Once humans had developed these capacities, once we could adapt to new challenges through culture instead of genetic change, the old rules of evolution no longer applied. We didn't need to evolve bigger brains to become smarter. We could simply learn more and create better educational systems. We didn't need to evolve physical traits for cold climates. We could simply invent warmer clothing and better shelters. We didn't need to evolve specialized digestive systems to use new food sources. We could simply invent cooking and food processing. The fossil record does not deceive. For the past 70,000 years, human anatomy has remained unchanged. Our brains have not grown, and our skeletons have not altered. Not at all. Our DNA has accumulated only minor variations. We are, physically and genetically, the same species as the people who survived Toba, who painted the caves in France, who first planted crops in the Fertile Crescent. What has changed is not our biology, it is everything around us. And that is exactly what you would expect from a species that traded evolution for culture. Survival of the fittest gave way to survival of the most innovative. In the fossil record, we see ourselves locked in biological stillness, while archaeological finds reveal a burst of cultural growth. Our physical evolution slowed as cultural evolution took over. This transition, that shift from biological adaptation to cultural transformation, occurred around 70,000 years ago, precisely when everything in the human narrative began to shift dramatically, when we turned into the species we remain, for good or ill, today. Now, if you've been following along, you might feel a question rising. Hold on, haven't humans kept evolving? What about the ability to digest lactose? What about thriving at high altitudes? And what about all those recorded gene shifts that have unfolded over the past few millennia? A valid point, since human evolution is indeed ongoing. Mutations still arise. Natural selection continues its work. Several populations have developed adaptations that aid survival in particular habitats. Yet here's the key distinction. This is essential for grasping what truly shifted 70,000 years back. These modern evolutionary adjustments are of a fundamentally different nature from the eras that preceded them. They aren't making us any more human, only fine-tuning our fit to specific surroundings. Picture it this way. Prior to 70,000 years ago, our evolution was composing the fundamental operating system, setting up hardware, constructing the apparatus from nothing. After that point, evolution has merely adjusted preferences, adding small software patches, and customizing configurations for various users. The core platform remains unchanged. Let's begin with one of the best-known recent evolutionary shifts, lactose tolerance. For countless millennia, all mammals on the planet shared a similar story. During infancy, they could process milk thanks to an enzyme lactase which digests lactose, the sugar present in milk. However, after weaning, the production of lactase ceased. Fully grown mammals could no longer handle milk. Once nursing ended, there was no evolutionary advantage to preserving that capacity. Then, about 10,000 years ago, an extraordinary event occurred. People in various regions of the world began domesticating cows, goats, and sheep. All at once, a vast nutritional resource appeared: liquid energy that could sustain communities through cold seasons and dry spells. Yet a difficulty arose. Adults couldn't digest this new food source. Consuming milk triggered bloating, cramps, and diarrhea, hardly the survival benefit one would seek. However, among each group that tended to dairy livestock, a genetic mutation started to spread. This small DNA adjustment allowed lactase production to remain active throughout adulthood. Now, those carrying this mutation could enjoy milk without discomfort. They obtained a steady food supply that their neighbors could not fully utilize. The benefits for survival and reproduction were tremendous. In Northern Europe, where dairy farming grew essential to the economy, lactose tolerance swept through the populace. Nowadays, over 90% of Scandinavians retain the ability to digest milk as adults. In East Africa, where herding cattle became a traditional livelihood, comparable mutations emerged on their own. Various genetic mutations led to an identical outcome: the ability to digest milk throughout life. The pace of this evolutionary shift is truly astonishing. Within a mere 300 generations, lactose tolerance transformed from an uncommon trait to the prevailing one. It's like watching evolution on fast forward. Natural selection performs its intended role precisely, promoting characteristics that enhance survival and reproductive success. Yet observe what remained unchanged. Lactose tolerance did not boost intelligence. It neither reshaped our brain architecture nor enhanced our ability for abstract thought. It did not modify our gait, our communication methods, or our information processing. It merely enabled certain groups to digest a particular type of food, one that other groups still cannot manage. This is a metabolic tweak, not a deep restructuring of human nature. Contrast this with the transformations that occurred prior to the population bottleneck and the mastery of fire, which demanded entirely novel cognitive skills. The rapid expansion of brain volume that revolutionized human intellect. The emergence of walking upright, which remodeled our entire skeletal framework and liberated our hands for crafting tools. Those were like core operating system upgrades, whereas lactose tolerance resembles merely turning on dark mode. Helpful in specific circumstances, yet not a transformative shift for humanity, and a similar pattern appears in adaptations to high altitudes. Some of the most striking instances of recent human evolution are found among communities residing at extreme heights. Both the Tibetan Plateau and the Andes Mountains rise above 12,000 feet, where the atmosphere holds roughly 40% less oxygen than at sea level. For the majority of people, prolonged stays at such altitudes are harsh, and the body strains to obtain sufficient oxygen. Altitude sickness sets in with headaches, nausea, exhaustion, and your blood becomes thicker as the body frantically generates extra red blood cells to transport oxygen. This blood thickening can cause severe health issues, higher chances of stroke, heart attacks, and clots. However, groups that have inhabited high altitudes for millennia have developed unique adaptations, allowing them to operate normally in thin air, such as the Tibetans, whose forebears migrated to the plateau around 30,000 years ago. They evolved genetic variations that stop their blood from overly thickening at altitude. Rather than generating extra red blood cells as lowland populations do, Tibetans keep their red blood cell levels relatively standard but utilize oxygen more effectively within their cells. The genetic alterations behind this adaptation are known. Variations in the EPAS1 and EGLN1 genes control the body's reaction to oxygen-deficient environments. These genetic variants appear in over 80% of Tibetans, yet are very uncommon in lowland groups. Astonishingly, the EPAS1 variant seems to have originated from Denisovans. Recall them? They were the long-vanished human relatives who mated with our forebears. DNA studies reveal that contemporary Tibetans acquired this high-altitude trait from Denisovan groups who inhabited the area many tens of thousands of years ago. It had already been evolved, tested, and demonstrated its effectiveness. Tibetans simply received a survival mechanism that another human species had crafted ages earlier. In South America, Andean communities devised alternative answers to the identical challenge. They have resided at high altitudes for a minimum of 10,000 years and have developed their own suite of adjustments. Contrary to Tibetans, Andean highlanders indeed generate extra red blood cells, yet they have also cultivated larger lung volumes and more streamlined oxygen transport mechanisms. These systems avert the hazardous consequences of blood thickening. The genetic foundation for these adaptations continues to be investigated, yet it's evident that they constitute separate evolutionary answers to the identical environmental pressure. Two distinct groups, two distinct genetic fixes, one fundamental issue. This is natural selection carrying out its function. Yet once more, consider what truly changed. Just the capacity to handle oxygen in a slightly altered manner. Adjustments in blood composition and lung size, fine-tuning of current systems instead of creating wholly novel abilities. These adaptations do not broaden human mental faculties. They do not generate fresh methods of communication or innovative social structures. They simply enable individuals to inhabit particular environments that would otherwise prove detrimental to health. The brain of a Tibetan Highlander and that of someone living at sea level are virtually the same. They share identical cognitive abilities, linguistic capacity, and capacity for abstract thought. Innovation in technology is also shared. The contrasts are purely physical adaptations related to how oxygen is delivered by the body to the tissues. These adaptations are crucial for surviving high altitudes, but not relevant to human evolution. Next, we have adaptations related to resistance to diseases. In recent times, infectious illnesses have produced distinct genetic imprints. The best-known instance is the sickle cell characteristic among people from areas where malaria is common. Malaria, caused by Plasmodium parasites spread by mosquitoes, is one of the most lethal illnesses in history. It has likely claimed more lives than any other infectious disease. Over thousands of years, billions have succumbed to malaria. In areas where the disease is widespread, a genetic change influences hemoglobin, offering some defense. Individuals with one sickle cell gene and one standard gene have sufficient modified hemoglobin. This alteration makes it harder for malaria parasites to multiply in their blood cells. Their risk of dying from malaria is greatly reduced. However, those who inherit the sickle cell gene from both parents develop sickle cell disease. This is a critical disorder where red blood cells are deformed and may obstruct blood vessels. From an evolutionary standpoint, this compromise is logical. In areas with high malaria prevalence, carrying one copy offers a survival benefit that outweighs the risk. Natural selection has kept this gene at high levels among impacted groups. This process has been ongoing for millennia. Comparable trends emerge with other sicknesses. In populations from areas where tuberculosis has been frequent, there is proof of evolutionary selection for genetic variations that grant immunity. European groups that endured plague epidemics possessed genes that aided their forebears in surviving Yersinia pestis. In every instance, evolution reacts to environmental forces. Here, it is diseases instead of altitude or nutrition. Genetic changes that convey survival benefits become widespread among populations. Those that don't are eliminated. This is natural selection functioning as Darwin outlined. Yet again, pay attention to the magnitude of these alterations. These are adjustments to immune system operation or blood composition. They are crucial for endurance, in particular disease settings. Yet they do not change the core essence of human thinking, interaction, or abilities. Someone carrying the sickle cell trait and someone without it possess brains that are alike. An equal capability for language and abstract thought exists. An equivalent aptitude for learning, creating, and innovating exists. The genetic distinction is significant for fighting malaria. It has no bearing on what makes us uniquely human. Next, we have skin color, frequently mentioned as proof of recent human evolution. The differences in human skin pigmentation are among the most apparent instances of adjustment to surroundings. Our earliest African forebears possessed dark skin with abundant melanin that shielded against strong tropical UV light. Melanin functions as a built-in sunblock, stopping UV rays from destroying folate. Folate is vital for DNA creation and reproduction. In regions with powerful, constant sunlight, dark skin offers a survival benefit. However, when human groups migrated to higher latitudes, they faced reduced sunlight. Ultraviolet radiation is required for the body to generate vitamin D. In tropical zones, despite dark skin obstructing UV rays, there is sufficient sunlight for vitamin D production. In northern areas, sunlight becomes scarce, and with too much melanin, the body struggles to generate enough vitamin D. A deficiency in vitamin D leads to rickets, weakened bones, and higher mortality. For groups migrating north, having dark skin turned into a drawback. Nature responded predictably through selection. Genetic variations that lowered melanin production spread among northern populations. Pale skin allowed greater UV penetration, which boosted vitamin D synthesis. Over millennia, groups at various latitudes developed distinct skin pigmentation levels. These were finely tuned to balance UV protection with vitamin D needs for their surroundings. The genetic alterations behind skin color differences have been pinpointed. Several genes influence melanin output. Different combinations of variants create the full spectrum of human skin tones. Some of these genetic shifts are surprisingly recent. The light skin in Europeans emerged within the past 8,000 years, partly due to farming and grain-heavy diets. These diets lower vitamin D obtained from food. Once more, we see evolution in action. Environmental pressures, genetic variety, natural selection, and adaptation all function as expected. Melanin production rates and pigment amount influence UV protection and vitamin D creation. This is vital for health in varying environments. It has absolutely nothing to do with thinking ability. An individual with dark skin and one with light skin possess the same brains, linguistic skills, and capacity for abstract thought. The difference is merely on the surface, a slight adaptation to different UV conditions. Are you noticing the trend? Each case follows the same pattern: environmental challenge, genetic variation, natural selection, adaptation. Yet the adaptations are always shallow. They involve tweaks to diet, altitude, disease, or UV exposure. They never affect the key traits that characterized human evolution before 70,000 years ago. No one has developed a larger brain in the last 10,000 years. No population has gained superior cognitive skills that others lack. No group has evolved new ways of communicating through biological changes. The core system set during the population bottleneck remains constant. What has changed are the settings, minor adjustments that help run the same software in various environments. We can measure how quickly evolution occurred before versus after these major transitions. Prior to the bottleneck, brain size grew by roughly 400%. From Australopithecus with 400 cubic centimeters brains to Homo sapiens averaging 1,400 cubic centimeters is an enormous transformation. Body form changed entirely. Ape-like features shifted to modern human proportions, suited for walking and running. Tool usage moved from none to highly advanced, requiring years of practice. These were fundamental changes that produced a completely different kind of being. They took place gradually over millions of years, fueled by strong natural selection. Then came the bottleneck and the cognitive revolution. The pace of major evolutionary change slowed dramatically. Over the past 20,000 years, our brains have actually shrunk a little. Compared to our ancestors, our brains are slightly smaller, yet the overall structure of our bodies has stayed more or less the same. Thanks to improved nutrition, we tend to be a bit taller these days, But if you look at the skeleton, it's virtually the same as what humans had 50,000 years ago. The modifications we've seen, like being able to digest milk, adapting to high altitudes, resisting certain diseases, and changes in skin color, all took place much more quickly than the earlier big shifts. These changes happened over just a few thousand years, not hundreds of thousands or millions. But even so, they're quite minor when compared to before. They're really just metabolic tweaks, not the birth of entirely new abilities. And this supports the main point perfectly. Evolution hasn't come to a halt. The processes are still at work. Genes keep mutating, and natural selection continues to favor those traits that help us survive and reproduce. Human groups still adapt to where they live, but what evolution focuses on has shifted dramatically. Before 70,000 years ago, evolution was busy working on the hardware, making bigger brains, reshaping bodies, laying the biological groundwork for complex thinking. After 70,000 years ago, evolution started tinkering with the peripherals, tweaking digestive systems, fine-tuning how we handle oxygen, and adjusting immune reactions. The core machinery isn't being upgraded anymore. Some scientists believe this marks a major change in the way evolution works in humans. They refer to it as moving from biological evolution to cultural evolution. The idea is that once our cognitive skills and cultural sharing were advanced enough, we started adapting mostly through learned behaviors instead of genetic alterations. Take surviving in cold climates. Before 70,000 years ago, you'd develop physical cold adaptations over hundreds of thousands of years, thicker body hair, a more efficient metabolism, and different body shapes. After 70,000 years ago, you create fitted clothing and figure out how to build warm, insulated shelters. You adapt through culture within a single generation instead of waiting millennia for biological changes. Now, consider finding new food sources. Before 70,000 years ago, you'd evolve digestive adjustments over enormous stretches of time. After 70,000 years ago, you develop cooking methods and ways to process food so that new items become digestible without any genetic shifts. What about competing with other species? Before 70,000 years ago, you'd evolve physical advantages, larger bodies, stronger muscles, improved natural weapons. After 70,000 years ago, you create better tools and hunting techniques that make those physical advantages unnecessary. When culture began evolving more quickly than genes, biological evolution was no longer essential for surviving in new places. We had found a shortcut for adaptation. Being able to learn from one another and pass on complicated knowledge through generations allowed us to adapt to almost any environment without needing natural selection to tweak our genes. That's precisely why the recent evolutionary changes are so telling. They occur in places where culture can't step in easily. You can't just learn to tolerate lactose. Either your genes let you digest milk, or they don't. And you can't teach your body to work better at high altitude. Your physiology has to adapt. You can't study your way to resisting malaria. Genetic modifications in blood chemistry are needed. These are the areas where biological evolution continues to act. These are the spaces where cultural adaptation cannot entirely replace genetic change. And even here, the evolutionary shifts are small, more like fine-tuning existing systems than inventing entirely new ones. This stands in stark contrast to the evolutionary shifts that occurred prior to cultural transmission, reaching a level of sophistication that could shoulder the adaptive load. Those earlier transformations, the tripling of brain volume, the total reorganization of the physique for walking upright, the formation of neural pathways for elaborate language, could not be bypassed through culture. For these were the very changes that enabled culture to emerge. One cannot possess advanced cultural transmission without having first developed the brain structures that facilitate it. You cannot create intricate technologies without first evolving the mental capacities to imagine and acquire intricate skills. You cannot construct extensive collaborative communities without first evolving the social acumen to manage complex interpersonal dynamics. The physical infrastructure had to be constructed before the programs could operate. And the population bottleneck roughly 70,000 years ago essentially finished that hardware setup. What remains is a species that continues to evolve in small ways, but has ceased evolving in significant ones. The more recent adaptations, as genuine and well-recorded as they are, function on an entirely different magnitude compared to the transformations that originally forged humanity. A Tibetan's adaptation to high elevation does not render them more human. A Northern European's ability to digest lactose does not broaden their humanity. An African sickle cell characteristic does not introduce new facets to human awareness. These are mere annotations to the saga of human evolution. The principal narrative was composed hundreds of millennia ago, culminating in the cognitive transformation that emerged after the bottleneck. All subsequent developments have been small adjustments, significant for the individuals and groups involved, yet inconsequential in the broader context of what renders humans distinct among Earth's creatures. These are the exceptions that confirm the rule. Evolution does persist. However, the era of substantial human evolution concluded 70,000 years in the past. What came prior constructed the human apparatus. What came after merely fine-tuned parameters for local environments. The distinction is far from subtle. It's the disparity between authoring a book and correcting errors, between erecting a home and selecting paint shades, between founding a species and refining its particulars. Human beings ceased evolving in the aspects that count. We continue to evolve in the aspects that do not. Thus, here we remain, the sole surviving human species. The offspring of 1,280 individuals who narrowly avoided extinction 900,000 years ago. For countless millennia following that bottleneck, we changed swiftly. We cultivated larger brains, advanced language, technological breakthroughs, the ability for conceptual reasoning. We dispersed across the whole globe, adjusting to each habitat from northern ice fields to equatorial jungles. We survived longer than Neanderthals, Denisovans, and all other hominins that shared our lineage. Yet then, an extraordinary event took place, an occurrence unprecedented in the entire chronicle of life on this planet. We halted evolution, or, to be more accurate, evolution ceased to be the predominant force molding humanity. That transformation occurred approximately 70,000 years ago, coinciding with the period when modern humans initiated their ultimate migration out of Africa. And grasping the reasons and mechanisms behind this tells us all we need to know about the essence of being human in the present age. The change was not abrupt. It was not akin to someone toggling a switch and human evolution simply coming to a halt. It proceeded slowly, a consequence of cultural evolution eventually surpassing biological evolution as the primary driver in human progress. For eons, our forebears adjusted to their surroundings in the traditional manner via natural selection. When temperatures dropped, groups that chanced to possess genes for more robust frames or superior fat retention were more likely to survive. Across many thousands of generations, these characteristics grew more prevalent. This is how Neanderthals acquired their sturdy physiques and broad nasal cavities. This is how Denisovans became suited to high elevations and coastal settings, unadulterated Darwinian evolutionary processes. However, modern humans had discovered something that completely revolutionized the game. We mastered the art of adapting more swiftly than our genetic code could alter. The weather turns chillier. Rather than waiting 10 millennia for evolution for a sturdier frame, simply create warmer garments, construct more secure dwellings, master the art of managing fire. The sources of food begin to vanish. There's no need to await your digestion to acquire fresh skills. Instead, devise novel methods for hunting and experiment with various foods. Create implements that allow you to handle items previously inedible. This is what archaeologists refer to as the cognitive revolution. It wasn't a genetic transformation, though genes enabled it, but it was a cultural leap that occurred with astonishing swiftness compared to biological evolution. Roughly 70 millennia ago, Homo sapiens acquired behavioral modernity. This included symbolic reasoning, intricate speech, advanced craftsmanship and tools, and crucially, the capacity to exchange wisdom among communities and across ages. All at once, a beneficial invention no longer required millennia to propagate via genetic transmission. It could disseminate through education within a single lifetime. One ingenious person discovers how to fashion a superior spear tip then passes the knowledge to their offspring and those nearby. In just 2 or 3 decades, every group in the area adopts the upgraded pattern. That's cultural evolution at work, a process that ticks along at an entirely distinct pace from biological change. The evidence left in the ground plainly displays this rapid shift. For countless millennia, stone implements altered at a glacial crawl. Hand axes dating back 1.5 million years appear nearly the same as those from 500,000 years ago. Yet following the 70,000-year mark, tool designs began accelerating. Fresh inventions emerged every few millennia, then every few centuries. By 20,000 years ago, diverse human communities only a few hundred miles apart were employing entirely distinct tool technologies, each tailored to their own local surroundings. Such cultural flexibility meant that the forces of natural selection, which had molded our forebears for eons, abruptly lost much of their strength. Those who endured were not necessarily the mightiest, nor those with superior chill climate traits or most effective digestion. Instead, the survivors were the quickest learners, the most capable instructors, those who could gather and circulate wisdom inside their communities. And that leads us to the central question. If human evolution effectively halted 70 millennia ago, does that imply we have stopped changing? Will we appear identical 100,000 years from now? The response is not straightforward. Human evolution hasn't truly ceased. It has merely decelerated until it's nearly imperceptible next to cultural transformation. Moreover, what evolution is favoring has shifted enormously. Let's examine what has genuinely occurred in human genes over the past 70,000 years. A handful of alterations have emerged, and they are quite telling. The most apparent are surface-level adjustments to various habitats. Differences in skin pigmentation assist distinct groups in handling sunlight. Paler skin in northern regions to optimize vitamin D production from feeble sun rays, and darker skin near the equator to guard against ultraviolet harm. Also, body shapes that aid in regulating temperature, leaner frames in warm areas, sturdier builds in cold ones. Yet observe what these transformations share. These are merely small adjustments to the human blueprint, superficial changes that don't alter our core essence. Our brains haven't grown remarkably bigger or much more intricate. Our fundamental body structure hasn't shifted. Our mental capacities stay virtually the same as those of people from 70 millennia ago. If you were to bring up an infant from those times in a contemporary household, they would be no different from any other kid. Identical intellect, language ability, and learning potential. The biggest evolutionary shifts have occurred in characteristics that aid digestion of foods brought by farming. For instance, lactose tolerance, the capacity to digest milk throughout life, emerged separately in various groups that tamed dairy livestock. Certain groups enhanced their capability to break down starches from farmed grains. Some adapted to life at high elevations or built immunity to certain illnesses. Yet these are outliers that confirm the general pattern. Their reactions to major environmental shifts, such as the rise of farming or moving to high peaks, were only small tweaks. Unlike the drastic changes that marked earlier human development, nobody is growing larger brains or gaining entirely new skills. We're only fine-tuning the current setup. The explanation is straightforward. Cultural adaptation outpaces biological evolution by so much that genetic mutations seldom have a chance to offer meaningful benefits nowadays. Before natural selection can ever promote a genetic variation that aids survival in a new setting, people have already created cultural fixes that benefit all. Why evolve genes for cold resistance when you can wear clothes and live in heated buildings? You don't require genetic changes to handle novel foods when cooking methods render nearly everything digestible. Thus, in a practical sense, human evolution in any significant form ceased roughly 70,000 years back. We arrived at a setup that was adequate and adaptable, allowing us to tackle nearly any difficulty via culture and tech instead of genetic modification. We got stuck evolutionarily not from achieving perfection, but from inventing tools that rendered further evolution mostly superfluous. Yet today we're dealing with the fallout of that evolutionary standstill. Here's what many folks fail to grasp. We inhabit bodies and minds shaped for a world that's vanished. Our physical makeup was fine-tuned for the hurdles our forebears encountered during and right after the genetic squeeze. Thinly spread bands of foragers, perpetual mobility, fluctuating food supply, prevalent physical threats, tight social circles of at most around 150 individuals. That era is over, yet our bodies remain unaware. This phenomenon is termed evolutionary mismatch by researchers, and it clarifies a great deal regarding contemporary human well-being and behavioral issues. Take obesity, for example. Back in the environment our ancestors adapted to, energy from food was limited and erratic. Discovering a dense supply of fats and sugars, such as honey or ripe berries, was an uncommon event. Evolution heavily preferred individuals who would binge on such items, and when they did, storing maximum energy as body fat to prepare for lean periods. That was entirely logical 70 millennia ago. Now, with dense fats and sugars accessible round the clock at every convenience store, that identical genetic blueprint is harming us. Our physiology still operates as if famine is perpetually imminent. We intensely desire high-calorie edibles. We find it hard to cease consumption when plenty surrounds us. We hoard fat with great effectiveness. These traits provided survival benefits during the glacial era, yet they are health catastrophes in today's industrialized world. The identical principle holds for our stress reactions. Our forebears confronted direct physical threats, predators, unfriendly tribes, environmental perils that demanded immediate fight-or-flight responses. Your body's stress mechanism, the sequence of hormonal and bodily alterations occurring when you sense danger, developed for those sorts of trials. Brief, intense pressures that could be resolved by physical movement. Yet contemporary stress is entirely distinct. Concerns about job stability, money troubles, and anxiety from social platforms. These are ongoing mental pressures that our ancient stress system never evolved to manage. You cannot physically battle your home loan or escape from your education debts. Consequently, your system remains on high alert, flooding you with cortisol and adrenaline over issues that no physical response can fix. The outcome includes heart conditions, panic disorders, despair, and a weakened defense system. The ancient survival mechanism you inherited attempts to handle modern-day challenges, or let's examine our social tendencies. Our species developed in tiny communities where everybody was familiar. Your very existence relied on keeping positive ties with perhaps 150 individuals, and you would likely recognize most of them throughout your lifetime. Evolution through natural selection preferred those skilled at interpreting social signals, creating deep connections, and upholding their status among the tribe. We grew incredibly attuned to being accepted, or cast out, because within a compact hunter-gatherer clan, exclusion could truly mean a fatal end. Jump ahead to the present, and we inhabit metropolitan areas populated by millions, encountering numerous unfamiliar faces each day. We maintain links with thousands via online networks, and our Stone Age minds feel utterly overloaded. We feel nervous in social settings because our danger-identifying mechanisms perceive a crowd of unknown individuals as a possibly hazardous circumstance. We fixate on our digital persona because our built-in desire to safeguard our standing makes no distinction. It fails to separate our real-life circle from the countless individuals who could view our content. We experience isolation even though we're more intertwined than ever before, as our instincts for forming close ties become swamped. These inner processes were fine-tuned for tiny, steady communities, not for enormous, ever-shifting social webs. Our rest cycles themselves are out of sync with contemporary existence. Our forebears followed the rhythms of daylight. They lacked electrical illumination that would keep them alert well past dusk. They had no mobile devices bathing their minds in blue glow, which reduces melatonin creation. Their daily routines match the sun's path. Nowadays, we take on nighttime jobs and browse displays deep into the night. We subject ourselves to manufactured brightness at every hour. And then we puzzle over the widespread occurrence of rest disturbances. Our internal body clocks continue to operate according to primordial instructions. This clash also reaches into our thinking shortcuts. People are really poor at evaluating probability-based hazards. We overvalue the peril of uncommon yet sensational dangers, such as acts of terror or aircraft accidents. We disregard frequent but ordinary dangers, including cardiac issues or automobile collisions. What's the reason? The mechanisms we use to gauge risks developed in a setting where sudden, striking dangers arose. such as predator strikes or hostility from other tribes. These posed the primary fatal perils. Those among your lineage who worried excessively about immediate threats outlived those who dismissed them lightly. However, in today's world, the most significant dangers to your well-being are ongoing and based on statistics. Those very impulses misguide us. We also struggle greatly with forward thinking. We heavily undervalue future outcomes, choosing instead short-term payoffs. Tomorrow was so unpredictable that fretting over it frequently seemed useless. If you could easily perish before spring arrived, it would be foolish to save money for decades ahead. Yet nowadays, the majority in industrialized nations anticipate a lifespan of 70 to 80 years. Our failure to put lasting repercussions before fleeting enjoyment creates huge difficulties. Global warming, pension funds, community health, each big test we encounter demands planning many years in advance. And our ancient minds find this truly tough. So, what does all of this imply regarding the path of human development? Is there a chance we will undergo major transformation once more? Or are we forever confined to our present state? The truthful response is that we lack certainty, yet we can form some reasoned predictions grounded on our knowledge of evolution and the forces that are molding humanity at present. In developed nations, conventional natural selection has grown nearly obsolete for people. Contemporary medical practices imply that genetic differences, which would have been deadly several centuries ago, no longer hinder individuals from living and having children. Nearsightedness, diabetes, heart ailments, and many more inherited problems that evolution would have eliminated are now controlled through spectacles, insulin, and drugs. We have basically chosen to bypass the survival of the fittest. Nearly every person survives. Nearly all individuals are able to have offspring if they desire. This does not imply that human genetics remain completely static. Some selection continues, yet it depends on distinct criteria from those in our ancestral history. The number of offspring people have, known as reproductive success, fluctuates according to cultural, economic, and individual circumstances. These elements are unrelated to genetic fitness as traditionally understood. In certain groups, individuals with particular personality characteristics or economic standing tend to have larger families. Elsewhere, distinct influences determine birth rates. Across many millennia, this might result in genetic shifts, yet they would be propelled by contemporary societal factors rather than natural forces. Additionally, novel selection pressures could arise. Changes in climate may bring about environmental obstacles that give advantage to some genetic types. Emerging illnesses could prompt selection for particular immune system genes. The movement and blending of populations keep rearranging genetic diversity in fresh patterns. However, any such transformations would demand millennia, or even tens of millennia, to yield observable effects. Adaptations in culture will almost definitely occur more swiftly. The genuine unpredictable factor is technological advancement. For the initial occasion in the entire story of life on our planet, one species possesses the ability to seize command of its own development. We have not reached that point currently, yet the elements are coming together. We are capable of deciphering the complete human genetic code. We can alter genes with ever-growing accuracy. We are starting to comprehend the hereditary foundation of intricate characteristics such as intellect, temperament, and illness immunity. In the span of mere decades, perhaps 100 years at the maximum, a decision will arise. That decision is one that no other species has ever had to make. Should we begin fashioning our own offspring? Should we modify human embryos to eradicate hereditary disorders, or to boost mental acuity or bodily abilities, or to adjust ourselves to novel surroundings such as different planets? This is not fantasy. The tools for fundamental genetic alterations are already in place. The issue is not whether we will possess the power, but rather if we will opt to employ it, and in what manner. This capacity for genetic manipulation signifies an entirely distinct form of evolution. It is not the blind process of natural selection spanning eons, but deliberate, guided modifications occurring within a single lifetime. Such technology would be immensely potent and immensely hazardous. We might erase hereditary illnesses that have inflicted boundless misery. Similarly, we could generate unexpected difficulties, amplify disparities, or transform the essence of humanity in unpredictable manners. Certain researchers believe we will integrate with our machines in an even more immediate fashion. Neural computer links that amplify our mental faculties and synthetic organs that surpass their biological counterparts. Also, microscopic robots that mend cellular harm and prolong existence without limit. At a certain stage, the boundary between a natural human and a cybernetic human grows indistinct. Do we remain the same kind if 30% of our brain consists of computer processors? If we have substituted our natural organs with manufactured versions? If we have modified such a large number of genes that we are genetically different from our forebears? Other people suggest that machine intelligence will render human evolution completely pointless. Should we construct devices that exceed our own intellect? They could emerge as the prevailing type of intelligence on this planet, with organic humans either combining with them or growing outdated. Clearly, this is conjecture. Yet, it is worthwhile to contemplate that evolution may not have concluded its work with intelligence on Earth. Perhaps it is merely transitioning to a non-organic foundation. Let us return to what is tangible and certain. In the near future, definitely for the coming millennia and likely far beyond, people will continue to be fundamentally unchanged in a biological sense. We will persist as Ice Age hunter-gatherers, inhabiting a world we have reshaped almost beyond our ability to recognize. We will keep facing the tension between our ancient instincts and the world we live in now. Grasping this mismatch is profoundly useful. Once you realize that your desire for sugar and fat is an evolutionary leftover from an era when calories were hard to find, making mindful decisions about what you eat becomes simpler. And when you see that social anxiety is simply your ancient danger detection system going off falsely, you can handle it better. Once you accept that your brain is not built for long-range planning. Since your forebears seldom had lifespans long enough for such plans to matter, you can create routines and structures to offset that shortcoming. Our evolutionary past is beyond alteration. We are bound to these Ice Age frames and minds, yet we can learn about them, and that knowledge is a source of strength. We have the ability to shape our surroundings, our societies, and our tools so they align with our nature instead of opposing it. We can admit that we are evolutionarily out of sync with contemporary existence and actively work to solve the issues this misalignment causes. This is, in the end, what being human in today's world truly means. We are the species that ceased biological evolution while continuing to evolve through culture. We are the offspring of those who endured the worst population crash our species has ever known. We emerged from it with mental capabilities that would allow us to transform the whole Earth. Rather than relying on evolution, we can transform ourselves through learning and culture. Instead of depending on chance mutations and natural selection to do the heavy lifting, our evolutionary path is no longer inscribed in our DNA. It is now written in the decisions we make. And that truth is as frightening as it is thrilling. So here we stand, at the conclusion of a tale that started 950,000 years ago. It started with a volcanic explosion that almost wiped out human beings completely. We followed those 280 survivors across 117,000 years of intense struggle and adaptation. We witnessed their transformation as they came out of the bottleneck forever altered. We observed their descendants branching into 3 distinct species and spreading across the world. Now we have reached the most pivotal point in all of human evolutionary history. It is the instant when evolution ceased to be the main influence molding humankind. 70,000 years ago, an event without precedent occurred. Our forebears did not merely make it through the Toba disaster's aftermath. They rose above the typical laws of biological evolution. The intellectual revolution born from the bottleneck sharpened our abilities to perceive patterns, enhanced skills for recognizing patterns, a heightened capacity for abstract thought, and the brain structures necessary for intricate language. These changes bestowed on us a power that no other creature had ever held, the capacity to evolve through culture at a speed far exceeding biological evolution. Consider the implications of that. For 4 billion years, each organism on Earth has changed over time. Our planet has been forged by natural selection. Conditions shift, groups either adjust or vanish. Fresh difficulties arise. Evolution develops new answers, But this process requires many generations, hundreds of thousands of years, even millions for large transformations. Then Homo sapiens arrives, carrying the genetic inheritance from that population crash, and all at once, the former rules are no longer valid. The climate changes. Rather than spending countless generations waiting for evolution to supply us with thicker fur, we simply create clothing. When new predators emerge, rather than growing stronger teeth or sharper claws, we produce superior weapons. When food sources vanish, instead of adjusting our digestive systems over millennia, we devise new methods of food preservation and preparation within one generation. The proof is clear. In terms of anatomy, we are almost the same as the humans of 70,000 years ago. Identical skeletal structure, similar brain volume, the same fundamental body. Yet in culture, technology, and society, we are utterly transformed. Our ancient forebears would never have dreamed of farming, towns, writing, or the web. Still, they possessed the exact biological equipment we have. The difference wasn't in our physical forms. It was our mental programming, our traditions, our collective wisdom transmitted via education and imitation rather than DNA. That's what sets us apart. Many creatures exhibit cultural behaviors. Chimpanzees show youngsters how to use tools. Whales develop local dialects. Different groups of crows share skills across time. Yet no other species has turned culture into their main survival tactic. We are the only species that halted biological evolution because we mastered cultural evolution. Our bodies are still adapted for the Stone Age, yet we inhabit a contemporary world. Your mind is fine-tuned for recalling fruit tree locations and spotting dangers in high vegetation. Our guts are built for a diverse menu of foraged greens and the occasional meat. Our social nature formed for communities of 50 to 150 individuals, not sprawling metropolises. Our stress reactions develop to cope with direct physical dangers, not vague anxieties over loans or digital alerts. That sheds light on many aspects of today's human experience. We desire sweets and fats despite abundance. We become nervous in scenarios that present no actual threat. We find it hard to sustain bonds in groups exceeding a few hundred. We operate with ancient programming from 70 millennia ago on modern frameworks, and amazingly, it's still functional. Yet, here's the truly deep insight. That chromosomal merging, the signature of every bottleneck survivor, remains present today. All living humans have chromosome 2, the clear proof of our near disappearance. Gazing at any individual, regardless of culture or origin, you see another descendant of those 280 whom the catastrophe spared. We all share the identical genetic heritage. That core ability enabled our forebears to outsmart, outmaneuver, and eventually outlive every other hominid. That's far more than a mere scientific truth. This is a powerful declaration of our shared humanity. The genetic variations among human groups are minuscule. We have been apart for at most 70,000 years. In evolutionary timeframes, that is negligible. We constitute one species, one extended family, all emerging from that same population crash, all heirs of the same intellectual leap, all demonstrating that culture can override biology. So, what implications does that have for our future? If we ceased biological evolution 70 millennia ago, are we permanently limited to prehistoric minds? The response isn't straightforward. Indeed, potent natural selection has mostly ceased influencing human groups. We no longer evolve larger brains or enhanced immune defenses. Yet we are acquiring something perhaps even more mighty. We are crafting technologies that could allow us to utterly surpass biological constraints. Medical treatments that remedy ailments evolution didn't equip us to handle. Devices that amplify our perceptions and capacities far beyond what natural selection ever yielded. Possibly even gene editing that lets us intentionally direct our own evolution. Instead of leaving it to blind natural forces, we are poised at another pivotal juncture in our species' story. Similarly to how our forerunners 70 millennia ago found themselves at the fork between biological and cultural change, we now stand at the junction between natural and deliberate evolution. The decisions we take today will influence not only our culture, but possibly our very physical makeup. As we conclude, I'd love your input. If you've listened this long, you're obviously captivated by this tale of humanity's origins and its relevance today. Tap the like button if this video shifted your perspective on human development. Subscribe for further explorations of overlooked episodes in our collective past. And crucially, leave a comment revealing your location. Are you in Africa, the birthplace of our kind? In Europe, where we survived alongside Neanderthals? Or in Asia, where we integrated Denisovan heritage? Everyone viewing this content belongs to that narrative. You are a real-life heir of the most extraordinary endurance saga ever recounted. When you next glance at your reflection, recall its true meaning. Not merely a single being, nor only a participant in your community or country, but an ambassador of the species that overcame annihilation. You rose above biology and mastered the art of transforming the planet. We are Homo sapiens, the insightful humans, the survivors of the genetic bottleneck, the species that halted evolution because we discovered a superior way, and that is a heritage to cherish. Sleep peacefully.